All right, next section of notes, you guys. Now remember, again, you can always pause this if you need to catch up with notes or if I'm going too fast. So today we're going to divide with radicals. Now, dividing with radicals is also known as, AKA, rationalize the denominator. Because divide is like a fraction, right? Radicals. So dividing radicals. Rationalize the denominator, meaning there's a radical in the denominator. Division sign. These problems will look like fractions, but it's really a division problem. So we call it rationalizing the denominator because it is illegal to have a radical in the denominator. You can never have a radical, square root, right, in the denominator. If there is a radical in the denominator, you must fix it. So, we're going to follow some easy steps to make this happen. Step 1. You can skip step 1 and go straight to step 2. It just means a little bit more work at the end. So I like to keep step 1 in there just because it makes life a little bit easier. But step 1 can be skipped if necessary. So we're going to simplify the radicals. Again, this can be skipped. Sometimes it's skipped because you can't simplify. They're already simplified. It's as easy as it's going to get. Or you can skip this. It just means extra simplifying at the end. Step 2 you have to do. So, when there is a radical in the denominator, you're going to multiply the numerator and the denominator by the radical in the denominator. You're going to multiply the numerator, top, and the denominator, bottom, by the radical that's in the denominator. Then you're going to simplify. You have to simplify at the end. Sometimes you simplify at the beginning and at the end, or you can skip the beginning simplifying and just simplify at the end. No, if you skip step 1, you should do skip step 1, but you're saying, no, forget it. I'm not going to simplify that. There's extra simplifying at the end. You'll just have to do a little bit more work. Numbers tend to get bigger. But you can, and I'm going to show you both ways, and it'll be okay. All right, here we go. So let's start off easy. Radical 2 divided by radical, or radical 7 divided by radical 2. You can never have a radical in the denominator. Right here. Boop, boop, boop. I've got one. All right, so here, let's follow our steps. Simplify the radicals. All right, can radical 7 be simplified? No, 7's prime. Can radical 2 be simplified? No, 2's prime. So I can skip step 1. There's no simplifying to do. Step 2, multiply the numerator, the top, and the denominator, the bottom, by the radical in the denominator. So I look at the bottom. My radical is radical 2, so I have to do that to both. Remember our rules of multiplying. Multiply the coefficients, multiply the radicands. So I look, there's no coefficient, so this is radical 14 over radical 4. If I look at 14, the only factors are 2 and 7. Are either of those perfect? No. So it stays radical 14 over radical 4. The square root of 4 is 2. And that's the answer. Try a little bit harder. 4 radical 2 over radical 6. Okay, so simplify the radicals. Can radical 2 be simplified? No, it's prime. Radical 6, okay, let's look. Factors of 6 are 2 and 3, but neither of those are perfect, so I can't. So step 1 is skipped. Step 2, multiply the numerator and the denominator by the radical in the denominator. So my denominator radical is radical 6. And I multiply the numerator by radical 6. Okay, rules of multiplying. Multiply the coefficients. So 4 times 1 is 4. And 2 times 6 is radical 12. Over 6 and 6 is radical 36. Step 3 is to simplify. Can you simplify radical 12? So let's look. 12, 2 and 6, neither of those are perfect, but 3 and 4, 4 is perfect. So that's 4 times 3 times 4 over radical 36. Square root of 36, oh, that's 6. Okay, keep going. So square root of 4. The square root of 4 is 2. So 4 times 2 is 8. Radical 3 over 6. Not done yet. That's a fraction. 8 over 6. Ooh, I'm going to have to squeeze it in there. They're both divisible by 2. So I'm going to put it down here. 4 radical 3 over 3. And that's my final answer. All right, let's keep going. Keep this train a-moving. If I had radical 11 divided by 6 radical 3, simplify the radicals. Can 11 be simplified? No. Can 3? No. Multiply the numerator and the denominator by the radical in the denominator. So just the radical. Radical 3. Radical 3. So that's radical 33 over 6 radical 9. You guys, here's the beauty of it. You are always going to end up with a perfect square in the denominator. Always. Because when you multiply 3 times 3 or 2 times 2 or 6 times 6, you're always going to end up with a perfect square because the same number times itself equals a perfect square. The same number times itself equals a perfect square. The same number times itself equals a perfect square. Can 33, radical 33 be simplified? 3 and 11, nope, neither of them are perfect. So radical 33 over 6 times square root of 9 is 3. Radical 33 over 18. So maybe right now you're saying to yourself, Mrs. Long, you told me simplify the radicals. First step, simplify the radicals. I haven't done that once. All right. How about now? Radical 20 over radical 8x. Okay. Can 20, radical 20, be simplified? Sure can. 4 times 5. there's a perfect, meaning it's 2 radical 5. Over, can 8x, yep, 2 times 4 times x, square root of 4 is 2 radical 2x. Simplify the radicals. So I simplified that first. Multiply the numerator and the denominator by the radical in the denominator. Okay, so the radical in the denominator is radical 2x, radical 2x. 2 times 1 is 2. 5 times 2 is 10x over 2 times 1 is 2 radical 4x squared. Can 10 be simplified? 2 and 5, no. So 2 radical 10x over 4 is perfect and x squared is perfect. So that's 2 times square root of 4, 2 times, I'm going to write this out, 2 times 2 times square root of x squared divided by 2 is x. So my answer is 2 radical 10x over 4x. Am I done? Nope. That can be simplified. So 1, I don't really need it, radical 10x over 2x. These x's cannot be simplified because this x in the numerator is under the radical sign, and this x in the denominator is not under the radical sign. Let's do one more. Let's do 8 radical 40 over 7 radical 30. You could skip step 1, simplify the radicals. You could just go straight to multiplying the numerator and the denominator by the radical in the denominator. You could multiply by radical 30 and you could multiply by radical 30. But if you do that, you're going to end up with radical 120 in the numerator, and sometimes that's too big. I don't want to deal with that. Maybe I'm going to have to. Like maybe there's no choice. Let's see. 2 and 15 for 30, 3 and 10, 5 and 6. So 30 can't be simplified. Let's check 40. 2 and 20, no. 4 and 10, ooh, 4 is. And 5 and 8, none of those. All right, so let's simplify 40. Let's make our lives a little bit easier there. So we have 4 times 10, which is radical 4, so square root of 4 is 2, so 8 times 2 is 16 radical 10 over 7 radical 30. I'm still going to have to multiply by 30, but it's going to be a smaller number, right? This was 1,200. I think I said 120 earlier. It's 1,200. I don't want to deal with 1,200. 300 is an easier number to deal with. Radical 30, radical 30, 16 radical 300 over 7 radical 900. All right, this is still crazy, but remember, you're always going to get rid of your denominator. That's why we do this. Square root of 30 times square root of 30, radical 30 times radical 30 is radical 900, but radical 900 is 30. I mean, basically what you're doing by multiplying a radical times its radical is you're just canceling out the radical and leaving that number. 300, I'm going to prime factor that. Let's do it down here. 300. So I have 10 and 30. I get 2 and 5, which are perfect. 30 is 5 and 6. 5 is prime. I said perfect. And 6 is 2 and 3. I look for pairs. I've got a pair of 2s, and I've got a pair of 5s. So I take one of those out. So 16, coefficient was 16, times 2 times 5. And what's left behind? 1, 3. Let's simplify that. 2 times 5 is 10, times 16 is 160. Radical 3 over 7 times 30 is 210. Not done yet. They both end in 0, so they can both be divided by 10. Here's another thing you can use your factor squares for. Do 16 and 21 share any factors? Let's look. 2, 8, 4, and 4 are 16s. And 21 is 3 and 7. No, they don't share anything. So this is my final answer. Remember, you can never, it is illegal, you can never have a radical in the denominator. What you do instead is simplify the radicals. This can be skipped. Multiply the numerator and the denominator by the radical in the denominator. And then simplify. So again, radical 7 divided by radical 2. I have a radical in the denominator, so I multiply the numerator and the denominator, top and bottom, by the radical in the denominator. So both get multiplied by radical 2. When you multiply the denominator by the radical that's in the denominator, when you double up that radical, it makes a perfect square every time, every single time. Meaning it makes a perfect square, so the radical disappears. Radical 6 times radical 6 is radical 36. That's perfect. It's 6. Radical 3 times radical 3, that's radical 9. That's a perfect number. It's really 3. Radical 2x times radical 2x is radical 4x squared. 2 times 2 is 4, x times x is x squared. It's perfect. The square root of 4 is 2. The square root of x squared is x. It disappears every single time. That's the beauty of rationalizing the denominator. Taking that radical out. Making it a true fraction. Rationalize, making it a fraction. Rational. Numbers that can be written as fractions. This is a fraction. You cannot have a radical in the denominator.